famous song by Jay-Z comes to mind. We've got 99 problems, haven't got enough money to fix them. So hopefully my presentation today fits in pretty well because the aim of it is to look at different prioritisation methods and help select the best management solution to achieve the biggest sort of bang for buck. Okay, so let's get into it. Let's start with the focus question. How do we best manage our waterways? And notice I'm not specifically talking about water pollution or water quality here. I'm talking about holistic waterway health. So just keep that big picture in mind, and we'll go from there. And hopefully we can draw a link from waterway health back to the specific pollutants that you guys are all trying to deal with. So, I use a risk approach. I think it's very valuable, and it's like the scalpel, cuts to the chase. Exactly what we need. So we start with values. We've got 4 key items here. Start with values. So yeah, you'll all be familiar. Waterway health. You've got aquatic habitats, and in Queensland, where I'm from, we've got the Great Barrier Reef. So this is just a jewel in the crown. It's worth $6 billion to the industry locally. So we've got a strong focus on protecting these values. Along come the hazards, and they're connected to the values via a risk pathway. So it's important to differentiate hazards and risk pathway. I'll explain a bit of that later as we go on. And the 4th key element is management actions. What can we do to interrupt that hazard and protect our values? So we've got values, hazards, risk pathway, and management actions. So 4 key items. Okay. Just before I get to the example, this is called a threat barrier diagram, and it's a model that can be simple at first, but it can be built up to quite complex systems to help paint the picture of what is the risk landscape that we're dealing with. Okay, so just an easy example, sediment. We can all acknowledge that it isn't helpful at times to the waterway, smothers aquatic life. Let's put it in our model that we've set up. We've got sediment on the left-hand side, water quality is our value, and we can use a sediment pond to intercept that sediment and protect our value. Does everyone remember this? Beijing Games. A serious problem with nutrients, I suspect. And it's a serious problem for the sailors trying to navigate the course. So it's a bit of a hazard. Putting this into our diagram, I've just got T and TP, you'd be familiar with the nutrients. Because they're soluble, the sediment pond won't pick it up. So you can see clearly that the nutrients bypass. So what can we do? I come from a stormwater background, and we treat most of the stormwater that comes off subdivisions these days, new subdivisions, and we use fire retention basins. So they're known as rain gardens, filter beds, that sort of thing. Good thing about them is they filter out the nutrients as well. They do a pretty good job. They also filter out sediments. So you can see from this diagram that the bioretention basin does the job of both the sediment basin, the sediment pond, and it adds in nutrients. So this diagram can be used to figure out redundancies, and it'll help you select maybe the best management action that looks after each of the different pollutants. So I invite you all to add in your own pollutants there, so arsenic or temperature or whatever you like. Okay, so just thinking about the broader application of this, we don't just have water quality as a value. We've got aquatic and terrestrial habitat. We've got coral reefs, so the marine system. Not forgetting also the social and the way humans interact with the waterway too. Economic productivity via fishing and things like that. And on the other side of the equation, the threat side of the equation, we've got the pollution that we've all been talking about, but let's not forget the natural threats as well, so weeds and exotic species. Yeah, we need to keep in mind the full picture. So if you chuck in flow change and natural disasters and climate change, then it adds up to a very complex picture for the potential waterway managers. Where do you invest? If you had $2 million right now, what project would you fund? And so this is the problem that waterway managers face. Where do you focus on? Commercial productivity or habitat? Okay, so we can use the threat barrier diagram that we've established before. Now, I don't expect you to read it, but generally I've got agricultural, urban, and here we've sorted it via avoidance of pollutant generation, mitigation, and then offsets. And is everyone familiar with offsets? It's like doing work somewhere else in the catchment to make up for some damaging pollution in your site. Okay, now the interesting thing is that in Australia, at least for stormwater pollution, we currently focus on just two threats, the sediment and the pollutants. And as a result, we rely heavily on two different management actions. They're the bioretention basin and gross pollutant traps. Gross pollutant traps pick up litter. And so if you stand back and look at the picture, there's a whole lot of things that we're not dealing with, a whole lot of threats. We're not using a whole lot of management actions. And this, starts the question in my mind, well, are we doing the right thing? Okay, let's return to the question. How do we best manage our waterways? Is it just enough to focus on the threats? Is it just enough to focus on the risk? Well, I'd argue no. You could have a concrete channel with super clean water running through it. You've got perfect water quality, but is that waterway health? I don't think so. I think we need to look at waterway health in terms of habitat, diversity of fish life as well. So it's not just enough to focus on the threat of pollution. We should look at a holistic picture and try to enhance the natural values that we have. Okay, so we had the risk side of the equation. Now let's look at the opportunity side of the equation. We've got some beautiful natural areas, conservation areas. We want to take them from a current state to a future state. How do we achieve that? So I'll introduce the terminology of bridges. Before we had a threat barrier diagram with barriers, but now we have an opportunity bridge diagram. So the bridge connects from the current state to the future state. And they're things that everyone's familiar with, rehabilitation programs, weed control, pest control, things like fish passage and fish ladders, and their opportunities to improve the natural habitat. And not forgetting ecotourism and things like that. So just to sort of sum up this section of my paper, on one side we've got the threat barriers, on the second side we've got the opportunities and bridges. So one's risk focus and the other one's opportunity focus. Okay, now I'd like to speak a little bit more about the risk pathway. And this is acknowledging that you need a whole bunch of things to line up in sequence before a hazard will interrupt a value and cause decline in that value. So there's things like the quantity and toxicity of the hazard of pollutant. And then there's things like the natural resilience of the value. With sediment, for example, it's very common in the natural environment, and river can adapt to prevailing conditions. Okay, so the important thing for this is that we need connection in order for the value to decline. And there's a number of different sort of dimensions, you're like. I've heard this brought up previously, so you'll be familiar with it. So we've got temporal, spatial, and resilience. And our management actions should aim to try and interrupt this risk pathway and stop the value decline. Okay, let's get into it. The temporal dimension refers to time, and this next graph is sort of like the stock price, stock listing of a given waterway. So the value goes up, value goes down. I don't know what the situation is in the creeks and rivers around where you live, but at least in southeast Queensland, there's a general decline. We're not lifting that price, the stock price up. So as we follow the value over time, we've got initial clearing of the catchment, we've got sediment leaving the catchment, a slow degradation via pollutants from roads and roofs and things like that. And then there's also, we need to acknowledge the key risks. So that's flash flooding, construction of fish barriers and clearing. The last little bit is natural resilience. We need to acknowledge that all the time nature is trying to lift up that value. So that's the worst case. The best case with human intervention is we manage the sediment. Is everyone familiar with water-sensitive urban design? It's a common term in Australia, but maybe not over here. It just means management of your water quality via urban design. And so we can do water-sensitive urban design, and that manages the slow degradation via day-to-day pollution. We can, maybe there's some key legacy items, like there's culverts that interrupt the flow of fish. We can remove them and rehabilitate streams, and they're called key opportunities. And then we can also give nature's natural resilience a bit of a push as well. Figure out what makes it tick, and then give it a push. So that's our best case. Now, we've been talking about what value, as in waterway health value. Let's drill down a little bit more and look at the needs of fish. So I believe when it comes to the crunch, waterway health for most humans on the planet is about the number of fish on the table for dinner. Some might argue differently, but let's just use this as an example. Now I've taken the hierarchy of needs from Maslow's hierarchy of needs. You might be familiar with it in psychology. Basic human needs, applied it to the fish. Now I haven't done any interviews with the fish, so I don't know what their needs are for self-actualization and their higher level needs, but we'll just start from the basics. So yes, these things can kill a fish within minutes. Oxygen, temperature, toxicants, pH and salinity. After that, if you don't have food and shelter, you might have fish survival for a week or two, So these are survival components. After that, you start looking at components that are needed for our fish to thrive. So the survival time scale goes up as you go up the triangle. So things like reproduction. A fish can survive quite long without reproduction, but it won't survive to the next generation. Interestingly, at least for the stormwater quality side of things like nutrients and sediment, they're important, but they're not the complete picture. Fish can survive in muddy water. And, in the Brisbane River, it's very muddy, and there's bull sharks in there, so we know that it's not such a big problem. So things like travel, schooling. By schooling, I don't mean education, I mean the need of fish to go in schools, habitat diversity. Let's look at the spatial dimension. So spatial refers to the distribution of values or threats throughout the catchment. And the key is it's not linear, it's not homogenous, it's not spread evenly. We've got pockets of high value areas and then pockets of low value. The reason why I bring this up is the problem with our stormwater legislation is that it treats the values as evenly distributed throughout the catchment. And it's a real problem. By the same token, the risks are not evenly distributed throughout the catchment as well. We've got areas that are starting to develop and they've got a lot of sediment coming off them, and areas that are well established where there's not much pollution. So why then does our management landscape be homogenous? You know, we've got a one-size-fits-all approach at the moment in southeast Queensland. We need to look at these critical priority areas and adjusting our funding regime to focus on them. So I'm calling them critical adjacencies, and they should be the priority areas. Now, cast your mind back to the opportunity management that we were talking about earlier. Why should we just focus on risk? In this particular case, we've got three opportunities. We've got the social opportunity, economic opportunity, and environmental opportunity within the catchment. And they may be disconnected from this waterway value. So we can design projects that link them. And they should also be on the table for consideration when the waterway manager with $2 million a year comes to decide, okay, what do I want to do? So there needs to be a balance between risk and opportunity, and there needs to be a prioritisation of funding to where it's needed most. So the resilience dimension, why do we need to consider resilience? Resilience, natural, as I mentioned, there's two types of resilience: natural resilience and then human-assisted resilience. I believe for flooding, it's important. In Brisbane, 2011, we had a major flood. I think it was a 100-year flood, and it caused great damage to the natural environment as well as to property and social values. And it just put things in perspective for me. Like we concentrate day to day on a lot of small first flush type pollutants, and then a big flood comes along and covers Moreton Bay with half a metre of sediment. So yeah, we need to consider exactly what's going on here. How can we manage this large threat? And it's an acute risk. I guess that's the problem. We've got chronic risks and acute risks. Okay, so putting this back into our diagram that we've established, we're doing the day-to-day management of sediment, nutrients, but along comes a natural disaster, or it may be a climate change or something like that, and it gets around our barrier that we've set up. And this is called barrier, I'm terming barrier bypass. And so it goes around the barrier, diminishes our values. I guess the best we can hope for is that if we haven't accounted for these large acute risks, that the values spring back after time. And that's through resilience. So that's why it's important to consider. Stockholm Resilience Centre has done a lot of research into socio-ecological resilience, and they've come up with 7 key items. So things you might be familiar with: diversity and redundancy, managing slow variables such as pollutants and things like that, but also encouraging learning and adaptive thinking. So, and I think that's really important, recognising changes within the catchment and tailoring your management response accordingly. Okay, now in my paper I talk about a number of different prioritisation tools. Today I'm just going to focus on a couple here. These are more standard engineering approaches and business approaches: hierarchy of control and cost-benefit analysis, whereas the triage and strategic planning you might be familiar with, but we'll talk about today. Okay, so triage approach. Triage is taken from the medical terminology of you've got limited resources, a disaster has happened, what can you do? So the way it works out in like on a casualty site is that all the attention and resources go to where you will have the biggest impact. So on the protect, on the side where you've got humans with, they'll survive their wounds, they're walking wounded, then you don't need to manage them so much. Whereas on the flip side of that, if you've got patients that have a very poor prognosis, they might not survive regardless of the treatment you do. So inadvertently, the attention focuses on the patients in the middle. So that's where the medical stuff. If we apply this to rivers, I've got 4 categories checked. I've made them rhyming, so you should be able to remember them. Protect, correct, resurrect, and neglect. So the protect category is the pristine waterways. You don't have to do much, but just remove those key risks if you can, and slow degradation. Correct category is about the waterways with issues that can cause a spiral out of control. So you just correct the path, the value path, and that might be weeds, it might be clearing. You stop the clearing in the catchment, things will settle down. The third category is resurrect, and that's all about those missing links. You've got pristine upper catchment, concrete channel, and then more estuary area. Maybe you can connect that missing link and rehabilitate and create that missing link. Lastly, and importantly, is the neglect category. And so I think this is really important, and it's often overlooked, but we have a finite level of resources and money to spend. We should acknowledge that, and we need to learn how to not spend on rivers and prioritise to better high value assets. Okay, so that comes to what we're calling back in the office the duck-buck ratio. So we want to get the biggest bang for buck, and that's what the triage approach is sort of talking about. How do we get the most, whatever your value is, per dollar spent? And now I've translated this into Spanish too, so the pesos por pesetas ratio. The final prioritisation tool I'd like to talk about, you will be aware of this, strategic planning, and that's basically recognising that not all areas of the catchment are equal. In the urban cities, city centres, we've got limited space, we've got a high population, we've got high land value normally. So the approach we choose is different from, say, if we were out in the rural areas. And we've got a lot more space to deal with, so we can do massive constructed wetlands if we want, but we need to recognise that we have a lower population base to enjoy any intervention that we do. So if we do a massive constructed wetland, it may not be appreciated by the general public. So if we go back to the CBD, there is that population base, and they can enjoy things like water features and fountains, but maybe not so in rural areas. So yeah, we need to recognise that not all areas of the catchment are equal. Okay, so just before I conclude, I'd like to talk about the human dimension. Now this is very important, and it's come up a number of times in the presentations we've heard, that we know the science, we know the engineering and how to treat these things, but when we try to get and implement these treatment devices, we struggle. And it's the implementation of these management actions. So we need a whole bunch of things to line up, and there are things like legislation, affordability. The last speaker was talking about they don't have the budget. So that's a definite consideration. And then there's the engineering items such as planning, design and construction. And we need all these things in order to get project success. So I believe this is a paper in itself, and I haven't gone into it in too much detail, but yes, it's the next step. Okay, so the key points of my talk: we need to broaden the focus, not just a specific pollutant. You can concentrate on the specific pollutant, but know where it fits within the bigger picture, I guess, is the message. And balancing risk and opportunity, you know, what does the catchment need? Are there any missing links? Understand and build, it's a bit hard to read there, but understand and build resilience. It may be that your particular waterway is fine, it has the carrying capacity for a large load of pollutants, you don't know. Or it could be very fragile and it may tip into another threshold state. We need to know those sort of things. And then, crucially, prioritisation of investment. I think it's critical. Let's divert funding for unnecessary things into where we can get biggest bang for buck, duck for buck, pesos por pesetas. Okay, as a final thought about prioritisation, let's think about the survival of not just the fish, but the human species as well. Okay, so only when the last tree has died and the last river has been poisoned and the last fish has been caught will we realise that we cannot eat money. Thank you.